Properties of matter. How can we describe the properties of matter? In this lesson, students will use models and experiments, along with this PowerPoint, to help them understand that each property has similarities and differences. All matter is made up of atoms, and atoms come together to form molecules. Here we see three atoms. Two of them are hydrogen, and one is oxygen. When these atoms come together, they form a molecule of water. The chemical formula for water is H2O. That stands for the two hydrogens and the one oxygen. Matter comes in three states: solid, liquid, and gas. We can describe each state by its properties. If you look at these pictures, you can see that each state of matter has slightly different properties, but some things are the same. Like each one has these round circles. These round circles represent atoms and molecules in the matter. Some types of matter share properties. A property is the way something is described. What types of matter have a definite, that means fixed, volume, or space they take up? Both solids and liquids can easily be measured to see how much space they take up. If you look here, the molecules in a solid object are all stuck together, and liquids, though they're moving, can be contained, and we can measure how much space they take up. So solids. Solid matter has a definite shape. It means a shape that can be seen. It also takes up a measurable amount of space. That's its volume. Here we see a ball, string, cotton balls, and salt. You can see they have a definite shape. Even if we were to untie the string, it would still be a string. And if we tore up a cotton ball, you would have just pieces of cotton, and they would each have their own definite shape. Liquids. Liquid matter can move around, so it doesn't have a definite shape. That means a shape that stays the same. Instead, liquids will take the shape of any container they are put in. Here we see a liquid in a container. And here we see a liquid out of a container. You see that it changes shape and moves over the rocks. Here we even see liquid metal. When metal is hot enough, it will actually turn into a liquid. Because liquids will stay in a container, their volume, amount of space they take up, can be measured. This liquid in a beaker can be measured because there are measuring lines on the side of it. Think like a scientist. Why do liquids need to be in containers? What would happen if a liquid wasn't in a container? If you said that liquid would spread out across the surface, you are correct. Although the molecules are close together, they will spread apart, and so liquids, if they're not in a container, will move across the surface. Gases. Gases have very different properties than liquids and solids. Because they are spread so far apart, they don't have a definite shape, and their volume cannot easily be measured. Here we see that gases have to be kept in special containers. If you open up the container, the gases will rush out in every direction. Gas molecules are constantly moving, and so they are very hard to measure. Make a tree map on your white paper for the three states of matter. In this part of the assignment, students will organize the properties of solids, liquids, and gases based on what they learned from their models, experiments, and this PowerPoint. Here is a list of properties of matter. Some properties describe one, two, or all three types of matter. Categorize the properties in your tree map. Let's take a look at a couple for examples. Here we see it says made of atoms and molecules. Well, if we think back to our first slide, we saw that all matter is made up of atoms and molecules. So, on our tree map here, under each column, we would want to write made of atoms and molecules. Made of atoms and molecules. And so are gases. We would write made of atoms and molecules. Some properties are shared with only one other type of matter. For example, has a definite shape. This one is actually only one of our categories. Whereas we see here has definite volume is two of them. Two types of matter can be measured. Use your models, experiments, and this PowerPoint to fill in your thinking map.